Lesson covers the CommManager and the light version of the CommManager, which is called PowerSync. CommManager is a ODBC driver for the mobile devices for Pocket PCs and for the older DOS portable data terminals. It establishes a database connection through the ODBC driver on behalf of each one of these handheld devices. Neither Pocket PCs nor their DOS counterparts are capable of creating a ODBC connection natively, and therefore the CommManager provides that connection for them. The CommManager communicates with each one of the mobile devices via IP packets. Visual App Builder is used to create the project on the handheld device that formats SQL commands. Those SQL commands are forwarded directly to the CommManager in an IP packet, and then the CommManager submits them to the appropriate database through the ODBC driver. When there's a result coming back, such as from a select statement, then the fixed length record that represents the results of that select statement are forwarded back in a IP packet back to the originating handheld device, and those are the primary functions of the CommManager. There are a few other things that it does, such as providing the current date and time to the mobile devices so they can all be synchronized with the same date and time, and version control for the Visual App Builder project that runs on the handheld device, so that if a Visual App Builder project is updated, it's simply copied. The settings for the CommManager can be accessed either through the Retriever Software Program group or through the Tools menu within the CommManager itself. They both cause exactly the same dialog box to be displayed. If you make changes in here, you will be prompted to restart the CommManager before those changes will take effect. The information that's displayed on the screen and when CommManager is running is contained in a text file called rfserver.log. You can find this file in the Retriever Software folder, and basically it's recording all of the SQL commands coming from the handheld and the responses going back to the handheld devices from the database. We'll go ahead and start up the application on a wireless handheld device now, and you'll see the messages coming in, and the log file, the rfserver.log file, will scroll across the screen. At any point you can go and open the rfserver log file just using Notepad. When the rfserver log file reaches 1 megabyte in size, it automatically renames itself and starts a new log file, and 10 log files are maintained so that the amount of disk storage spaces required for these log files never grows to more than 10 megabytes. These log files are zipped up and attached to the tech support email that's sent back to Retriever Software or back to an independent developer's specified email address. We'll go into deploying applications with tech support in a later training lesson. On our handheld device, we'll go ahead and select the test program that we've been working on, and it'll be downloaded to the Pocket PC in this case, and it'll actually run our application. If we choose to log on our application on our mobile device, and we go ahead and put in admin for our username and password and click OK on our mobile device, we can see the actual SQL command that came in from the Pocket PC. That's this line that says SQL select asterisk from test.employee, test being our data source name from our test project, where user ID equals admin. We got a 0 response back from the CommManager, from the database, that represent a positive response to our select command. That means a record did match our where criteria. If it had not matched, we would have gotten a 1 back to tell us that there was no records that matched the where selection criteria. And in that case, within our Visual App Builder project, we would go down the error branch instead of the OK branch for the next object to execute. So in this case, it went down the OK branch because we found a matching selection and the password was correct. So if we go ahead and tap on the sales order button on our Pocket PC and enter the sales order that we've got in our database, which is number 18, then we'll see the custom SQL command that is in our Visual App Builder project. This is the SQL custom bulk, and then the actual SQL command itself. And again, you'll see we got a 0 response back. That means there was more than one record that matched our selection criteria. You also see some messages here, a server message regarding a bulk 111.tmp. These are the temporary files that are sent down to the Pocket PC whenever we do a SQL bulk or a custom SQL bulk type of command. And then the files are renamed to the appropriate name on the Pocket PC themselves. So these would be the normal messages that you would see while the CommManager is running. PowerSync generates exactly the same rfserver.log file. The only difference between PowerSync and CommManager is the user interface. With PowerSync, an icon shrinks down to the taskbar, or the system tray in the lower right-hand corner of your Windows desktop, and as opposed to having a full-screen display of scrolling messages. It's really designed for users who are accustomed to using ActiveSync with a single Pocket PC working through a cradle to do its communications. Therefore, the need to see the scrolling messages go by is really not as relevant to a small user who's only using one device for a batch type of application. So it's designed to have a simpler user interface, and there is a restriction on the PowerSync for the maximum number of users that can communicate, synchronize through that particular user interface. Whereas with the CommManager, there really isn't any limitation other than the memory and the number of database connections that are available on the PC that's running the CommManager application. There are no special requirements for the CommManager PC. It needs to have ODBC connectivity to whatever database the mobile devices need to gain access to. But other than that, it does not need to be a dedicated PC. In a large environment with numerous dozens of mobile wireless Pocket PC devices, you would probably have this on a server type of machine that's being maintained by someone in the IT department. But the CommManager process itself is just a simple 32-bit multi-threaded application that really doesn't have any special hardware requirements. To the database itself, the CommManager looks like any other database application. It's simply making multiple database connections and issuing SQL commands and getting responses back through the ODBC API. And so to your database, it really cannot tell the difference between a PC just running any database client application and the CommManager process.